Good morning, dear students. My name is Ferhan Mazher, and today is 19th of April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a alternative to practical paper. We call it ATP. We also call it paper 4. Today, we have selected May June 2016, a 4-2 paper. This paper 4 belongs from the zone 2 or the variant 2. The time allowed for this paper is 1 hour and it has 30 marks. So let's start. So May, June 2016, 4-2 paper, paper 4, alternative to practical. 1 hour time is allowed. The question paper is showing up on your screen. So let's start. Here we go. So question number 1, he says a student investigates the oscillation of a meter rule. The student starts by supporting one end of a heavy rod using a stand, and boss and clamp. Figure 1.1 shows how he assembled the apparatus. Okay, so you can see here we have a retort stand, and this is the boss, this is the clamp, and here is that meter rod. So the meter rod is in that direction. Okay, so this is the stand, this is the base of that stand. Explain why this is not the best way to assemble one stand, boss and clamp to support a heavy load, because you can see the rod, which is heavy, is on the right side of this stand, and the base of the stand is on the left side. So what will happen when, because this is heavy, so it will produce a moment and this stand will fall to the right side. So that is the wrong thing, and because of the direction of this base, when the weight will come here, it will fall to this side. So that is our answer. So let's look at my answer. So here we go. This is my answer. Base of the stand is to the left, stand will fall to the right. Due to the weight of that rod, heavy rod, the chances are that the stand will fall to the right. So this is my answer. So let's have a look at the marking scheme. What the marking scheme says: clamp may topple, fall, tilt, bend, turn, become less stable because unbalanced, move clockwise to the right. This is the marking scheme. Okay, so the next part. In the space to the right of the figure 1.1, sketch a better way of assembling this apparatus. Okay, so here we have to draw this diagram again, but we should draw this in such a way that this problem can be overcome. So let me show you my answer. So here we go. So you can see I have drawn this diagram again, and this time the base of of that stand is on the right side of that stand, because when the heavy load will come here, if the base is in this direction, then it will not tilt to the right side. So that is the question they ask us. So let me look at sketch showing rod turned around the other way. Okay. Two clamps are used to support the rod horizontally. You see this clamp is showing here. So they have used two clamps. So two stands, two clamps to hold this rod in this horizontal position. Two clamps are used to support the rod horizontally, about 80 centimeter above the bench, as shown in the figure 1.2. The student is given a meter rule and two set squares to check that the rod is horizontal. Draw on the figure 1.2 to show how the apparatus is used. Explain how he can tell that the rod is horizontal. 1 mark. Okay. So the methodology is very simple. You see, you put a rod here, that scale here, or rule here vertically, and you check what is the height of this point, this end, from the base, from the bench. And then you use the same rule here, and keep it vertical and check what is the height of this point from the bench. If the both heights are same, then it means that this rod is horizontal. So now when you will be performing this, you have to make sure that this meter rule is vertical. So by placing here a set scale, you can make sure that the meter rule is vertical with the bench. And when you want to measure this height from the bench, you can use a set square here also to make sure to get the exact reading from the meter rule. So let me show you. Let me show you. Okay. So you can see here I have tried to make that diagram, and in this diagram you can see here we have made a rule, and here we have a rule, and this rule, and here I have put a set square. So here I have put a set square, and that set square, you know, so here we have a set square, and that set square will make sure that this rule is vertical. This rule is exactly vertical. And then I have used this set square in this manner. So it will avoid the parallax error. It will give you the exact what is the this reading on the rule, because there will be some little bit distance between the rule and this rod. So this set square, with the help of this set square, you will be able to tell what is the height of this rod on this rule. So you can do the same things here. So this is the diagram which we have drawn. Okay, now the second question was explain how he can tell that the rod is horizontal. So height of both ends of the rod from the bench is equal. The rod will be horizontal. So if you check the height of this end of the rod from the bench and this end of the rod from the bench, if both the heights are same, that means that the rod is horizontal. So this is how you will do this. And I hope that you have understood. So this is the rule, this is the vertical rule, this is the set square to make sure that the rule is vertical with the bench, and this rule, this set square, sorry, is used to take the reading of the height from this rule. Okay, so that's it. So if you look at the rule vertical by eye with two set squares correctly used, height above the bench at two places same. So that's the marking scheme. Okay, so let's go to the next part. He says the student suspends the meter rule from the rod, two pieces of thread of equal length. A half meter rule is placed on the bench under the meter rule so that the end A of the meter rule is above the 0 centimeter end of the half meter rule as shown in the figures. So with the help of the threads, they have hung a meter rule here. These are two threads and they have been tied with this rod. So this is a meter rule which is hanging with the help of these threads with that rod. And on the bench, we have put a half meter rule. And this end A of this meter rule is exactly above the zero of this half meter rule. Describe how the student can check that the end A of the meter rule is exactly above the 0 centimeter end of the meter rule, half meter rule. So how you can make sure that this is exactly above the 0 point? So you will use a plumb line. So plumb line is basically a thread, and at the one end of the thread, we have a heavy metallic ball, and it's like a cone at the end of the thread. So when you hold the thread due to the weight of the metal cone at the end of it, it always remains vertical. So what I will do, I will take a meter, I will take a plumb line, and I will hold my hand here, and in my hand I will have that thread, and that thread will be here. So it should be almost touching the end A, And if that cone, metal cone, will be above O, then it means this is exactly above. So this is the method. Let me show you my written answer. So you can see here I have drawn that diagram also. I have shown a plumb line here. This is the thread. Here I will be holding it. This is that metallic cone which is heavy, and this thread remains vertical. So this thread is almost touching this rod, A end of that rod. And if that cone, the vertex of the cone is above the zero, then it means that this point is above the zero. So their question is, okay, hang a plumb line, thread of the plumb line should close to A. Bob of the plumb line will be above O centimeter mark, 0 centimeter mark. I mean. So let me show you the answer. Okay, so a rule vertical by two set square close. Okay, this is done. Use of the vertical ruler or set squares or plumb line. We have used the plumb line. Okay. So what's the next question? He says the meter rule is moved to the left until the end A is above the 10 centimeter mark on the half meter rule. It is then released. As the meter rule swings, the amplitude of the swing decreases. So you vibrated the meter rule, and obviously, as it will swing on and on, the amplitude of the swing will decrease. The student counts the number n of the swings until the end A no longer passes the 5 centimeter mark on the half meter rule. He repeats this several times, and his results are shown below. So after 53 swings, the meter rule is no more crossing the 5 centimeter mark during its swing, and 55, 52, 51, 53 swings. So calculate the n average, the average value of the n, give you an answer to significant figures. So we will add these 1, 2, 3, 4, 5 figures, and then you divide the answer with the 5. So you will get the average. So here we go, 53 plus 55 plus 52 plus 51 plus 53 equals to, divided by 5 equals to, and that will be 52.8. And in two significant figures, it will be approximately 53 number of swings. So let me show you the answer, 50. Our answer is 53. So let's check what they say, 53. Yeah, our answer is right. The student is given one square piece of card of the side L. He attaches the center of the card to the end A of the meter rule with a small piece of the blue tack, and as shown in the figure 1.4. So they have taken a piece of paper which is in the form of a square, and they have attached that paper with the end A of that rod. So the value of the L is 19.0 centimeters. The student repeats the experiment in the C to obtain a value for the N average. He then cuts the card to make the square smaller and repeat the experiment with the smaller value of the L. So figure 1.15 shows the student's results. So when the rod is, when this paper at the end of the rod A is of 19 centimeter wide, 19 centimeter height, the number of swings are 3. When you reduce this paper by cutting the sides of this paper to 15, then 6, when 11, 12, when 7, then you have 22, when 3, it's 35, and when 0, 0 is that which you got there, 53 point. The result here you got 53. So you have to write here 53. Then the question is, complete the figure 1.5 by according to your value of the n average from the C second part for L equals to 0, that was 53. So you have to write 53 here in the table. On the figure 1.6, plot the graph of L centimeters on the x-axis, y-axis against the n average on the x-axis. Start your axis from 0, 0. Draw the smooth curve of the best fit. So we will plot these points, and this L is supposed to be on the y-axis, the N will be on the x-axis. So this is that graph which you have to draw. Let me reduce the size so you can see the whole graph, but this graph do not show up. So this is that graph. So first of all, we will draw this graph. So first of all, we will label this diagram. So an average I have taken on the x-axis, the L in centimeters is on the y-axis. So the values are going up to, N values goes up to 53. So here is 10, 20, 30, 40, 50, and 60. And the value of the L is from 0 to 19. Okay. So I have written here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then we will plot these points. We will plot these points. Okay. At 0, you have 53. At 3, you have 35. At 7, you have 22. At 11, you have 12. At 15, you have 6. And at 19, you have 3. So we will plot these points here. You can see I have plotted these points. So you can see I have plotted these points. And then I have joined them with the smooth curve. So this is that graph. Hopefully you can see that. It's a 4-mark question. Okay. The graph shows that as L decreases, N average increases. Two quantities and X and Y are inversely proportional if they obey the equation X is equals to K divided by Y, where K is a constant. By taking two pairs of the values from the graph, show that the N average is not inversely proportional to the Y. Okay. So we have to take the values from the graph and we have to show that they are not inversely proportional. For inversely proportional, the product of the two things should remain constant. So here you can see I have shown my answer. So I have taken 2 points 10, 12 and 30, 4.3 from the graph. So the K value for the first value will be 10 into 12, that will be 120. And then the second point is 30, 4.3 on that graph. So its K value will be 30 multiply 4.3, and that will be 129. So using the second point, okay. So because product of the N and N average and the L is not constant, so they are not inversely proportional to each other. So they are not inversely proportional to each other. So X is labeled quantity on both the axis and unit on the y-axis only, and X is correct way around. Scale linear, not awkward. Start from the 0, 0 points plotted accurately. Smooth best fit curve drawn. L multiply N average seen for one pair of values from the graph or table. Two correct values of the X, Y calculated and not equal comment. Okay. He just suggests why the student starts with an L of 19 centimeter and then reduces the L value rather than starting with the 3 centimeter and then increasing the L. You see, if I will use 19 centimeter long paper, and I will do the experiment for that length of the paper, and then I can cut the sides of the paper, and I can make it 18, I can make it 17, and then perform the experiment for the length of 17. And then I can further cut it, and then I can take the length as let's say 15, and then take the do the experiment for a paper of the length 15 centimeter. So if I start from the largest side, and gradually after performing the experiment, I cut the sides, and I make the length smaller for the new experiment. By doing so, one advantage which I will get is that the paper I use will be only one paper will be used. So with a single paper, I will be able to get all the values. But if I start from the first experiment with the smallest reading, and then obviously if I start experiment with the length 3 centimeter, and then I will perform the experiment for the 5 centimeter length, then I will have to get a new paper. So it's better to start from the largest paper and start cutting its sides to get the new lengths. And that will be easy. Only one paper will be used. But if you started from the smaller lengths, then you will need multiple papers for that purpose, for that experiment. So let me read my answer, and then we will check the. Okay, the fourth part is showing up on your screen. He says, starting with the L equals to 19 centimeter, and then cutting its edges to make squares of the smaller length will require only one paper. So it will need only one paper. You don't have to get many papers. So this graph is made. Okay, so we are going to the next question. The next question is question number. Marking scheme is showing up for the last part. Less card used can use just one piece of card. So let's go to the next question. Okay, a student investigates the path of the ray of light through a triangular prism. The figure 2.1 on the page 7 shows the triangular prism placed in the center of a sheet of the white paper. On the figure 2.1, on the figure 2.1, mark and label P, the midpoint of the side AB of the prism. Draw the normal to the prism at the P. Draw a line to represent a ray of light incident at P with an angle of incidence of 40 degree. So let's see what we can do. And that is figure 2.1. So let's go to the figure 2.1. So this is the figure 2.1. So let me reduce the size so you can see the whole figure. So here, still cannot see the whole figure. Okay, so this is the figure 2.1. Here, boundary of the prism is shown. We have to mark the midpoint of the AB, and then we have to draw a normal, and then we have to draw an angle of incidence of the 40. So very simple. Let me show you my answer. Okay, so first of all, question number 2, A part we have to. So what I will do, this is the boundary of the prism. So at the midpoint of the AB, I will call it P. I have drawn a normal. This red colored dotted line is normal. This makes 90-degree angle with the AP. Okay, then I will, with the help of the protractor, I will mark an angle of 40 with the normal, and I will draw incident ray. The incident ray will come and meet this face at the point P, and the angle between this blue and the red line is 40. This is the incident ray, and this is the angle of incidence. Okay. So figure 2.2 shows a ray box that produces a narrow ray of light. So narrow ray of light. So here the light is coming. So this is a box. Describe how the student can use the narrow ray of light to find the path of the ray through the prism. So it's very simple what you do. You see, You take a white paper and let me tell you how much are the marks. So it's a 4-mark question. These lines are given. So what I will do, I will take a white paper, I will fix it on a drawing board with the help of the pins, and then I will place a triangular prism in the center of the page as shown in the figure. I will mark its outer boundary. Then we will find the midpoint of the AB, and we'll put a normal here. And then with the help of the ray box, I will direct the light onto the face AB, and the light will touch the point P here and midpoint. Okay. So that white light will, when it will enter here, and from this face it will emerge. So the phase from where it emerges, what I will do, I will make 2 points on the paper. I will call them P3 and P4. And the light ray which is entering into the phase AB at the point M, I will trace its path on the paper also by putting the pins or by making marks on the paper from where the light is passing. And then what I will do, I will remove everything, and I will join these the 2 marks which I put on the incident ray with the straight line until it reaches this face AB, and from the face BC I will complete that ray path, which is the emergent ray. So from where the light emerges and from the layer the light enters, I will join them with each other, and that is the path of the light inside the prism. Hopefully you understand. Let me show you my written answer. So here we go. Light ray which emerges from the face BC, on that emergent ray mark 2 points P3 and P4 on the paper. Remove everything from the paper and join the P3 and P4 with the face BC with a straight line. Join the point of incidence on the line AC and the point of emergence on the line BC with each other. This is the path of the light in the prism. Very simple, straightforward question. Okay. So we have to mark these points. I think we have already done this. So I have found the midpoint of the AB and I call it M. I have drawn a normal here, and this is the incident ray which is making 40-degree angle. Okay, so I think the question is over. Yeah, the question is over. So we are going to the next question. The next question is, so we are going to the question number 3. A group of students measures forces using a set of bathroom scales. One student measures his weight by standing on the scale as shown in the figure. Figure 3.2 shows the reading on the scales when the student is standing still. State the weight of the student at this moment. This is 540. 540. 540 is the reading, Newton. Then their question is, state the weight of the student. We have done that. Explain why the student needs to stand still on the scale. If you do not stand still, what happens? The scale will continue vibrating, and the pointer will not become steady. It will be moving forward, backward, forward, backward. If he is not still, pointer of the scale keeps on moving or vibrating. So then the next question, explain why it is more accurate if the student takes the reading from directly above the scale. Whenever you see the scale from directly above it, actually you make your line of sight perpendicular to the scale from where you will measure the reading, and this helps to avoid the parallax error. So it says Parallax error will be avoided when line of sight is perpendicular to the scale. Okay. Then he says, let me show you from the other paper. Avoid parallax error moving changes the reading on. Okay, so we are going to the next. Explain why it is more accurate if the student takes the reading from directly above the scale. It avoids the parallax error. And that I don't have this answer. So that the box remains in the range of his arms. And okay, which part I am looking at here. So a parallax error will be avoided when line of sight is perpendicular to the scale. Okay, so they have put that weighing scale here on the side of this box, and this they will apply force on this scale, and this will move, and we will note down what is the maximum reading here. Very simple and straightforward question. He pushes the scales with both hands, and the other student notes the reading on the scale when the box just starts to move. Explain why it is important that the student pushing the box increases the force slowly. You see, when you are increasing the force, all of a sudden, what will happen? The body will start, or that box will start moving, and when it's move, the reading on the scale will change. So increase the force slowly so that he can record the maximum force applied before the box starts sliding. Okay, next question is suggest us reason why the student places the box near the edge of the bench. You place the box at the edge of the table so that you can reach it easily. So your hands can reach that box easily. So that the box remains in the range of his arms and he can apply force on the scale without leaning against the table. So we are done with the question number 3. Question number 3, the marking scheme for these parts is showing up. So I will show you. You can pause the video and you can read these answers. Okay. So now we are going to the next question. The next question is question number 4. He says figure 4.1 shows an empty large reel that was used to hold a ribbon. So ribbon is wound around this reel. The central cylinder has a diameter of about 3 centimeters. Two students use different methods to find the diameter of the central cylinder. One student uses a ruler and the apparatus shown in this is clamp, shown in the figure 4.2. This, when finding the diameter, the distance between point A and B changes as the screw is turned. Describe how the student measures the diameter. So what we will do, we will take that rod and I will put it between the A and B, and with the help of these screws, I will tighten them. Then I will remove that and I will check with the help of a scale what is the distance between A and B. So you will repeat this procedure on from the different locations of that body, and then you can take the average, and that will give you the average of the diameter. One mark question tha. Okay, so let me. Okay, hold the central cylinder between A and B, then using the scale find AB length, and that will be the diameter. Repeat from different locations on the central cylinder, and then take average. So this is the answer. Okay, the next question they are asking is, he says the other student measures the diameter using only the following apparatus: meter rule, pencil, blue tack, 1 meter of the thin thread. Describe clearly how he he can find an accurate value of the diameter. So the methodology is very simple. What you will do, you will take your thread, you will take your blue tack, and you will fix the one end of the thread on your on that cylinder, and then you will wind that thread around that cylinder. For example, you make 10 rounds around that cylinder, and then you will put a mark on that thread to know okay, how much length of the thread is used, and then make that thread straight and take it off from that cylinder and measure the length of the thread which is used to make 10 circles around that cylinder. And then I will apply, because 10 rounds means 10 circumferences. So 10 multiplied 2 pi r, that will be equals to the length. And from I know the length of the thread, the length of the thread very easily we can find. And I know because this thread was used to do 10 rounds around that cylinder. So it will be the length of the thread which is used is equals to uh, 10 multiplied 2 pi r. And very easily from there, I can find out the length of the diameter. It's a 4-mark question. So let me show you my answer. He says, he attached the thread to the central cylinder with the blue tack, wound a thread around the central cylinder. Cylinder count 10 turns and put a mark on the thread. So you made 10 turns around that cylinder, and then you put a mark on the thread. So on the thread, then measure the length of the thread to make the 10 turns around the cylinder with the help of a rule. Then use this formula. So D is equals to L by 10 pi, where D is the diameter of the cylinder and L is the length of the thread to make 10 turns around the cylinder. So very easily I can find the diameters. That's the formula, and I have done the homework here. That's rough work. Okay, this is not the main work. This is the rough work. So the length of the 10 turns will be equal to 10 multiplied 2 pi r. So it will be this 2 and r means diameter. So 10 into d and the thermometer. So the value of the d will be length divided by 10 pi. So the diameter will be length divided by 10 pi. So that was the question number 4. So my dear students, we have reached the end of this paper. So let's have a look at the marking scheme. So that is question number 3. And this is question number 4. You can pause the video and you can take your time. And so so my dear students, today we have done May June 2016 4-2 paper. And I have tried my best to explain you the concepts, and I have also tried to show the marking scheme with each part we have done. I hope you have learned something from it and you have enjoyed studying with us. So if you like this video and you think it's informative and this can be helpful for your 11th Cambridge class and your fellows in the 10th Cambridge class, even in the 9th Cambridge class, you can share the link of this video with your friends, with your families, and with your teachers and all the fellows who are in the O levels. So thank you very much, everyone. It's a great blessing for me to teach you online. Keep praying for us. Thank you very much. Have a good day. God bless you.